Good morning, good afternoon, good evening. Whenever you're watching this video, this is Math with Mr. Samuels and Ms. Brunell. Just like usual, before you start this video, please make sure that you have your notes so that you can follow along as we discuss. And at the end, yes, you will be doing specific practice problems that we will go over and post the answers in class. Everything is the same old, so let's get busy. Okay, so we're talking about transformations, and I know that in both classes we have already done an activity where you've already worked with a few of the different transformations. Okay, we have four different types of transformations. Okay, down here we have reflections, translations, rotations, and dilations. The one that we're going to focus on today is going to be reflections. Okay, so first and foremost, with all of these different transformations, a transformation is an operation that maps an original figure. That original figure is always going to be called the pre-image. Okay, and now we transform that pre-image onto a new figure, and that new figure is now called the image. Okay, so our original figure is always going to be the pre-image. The new figure will always be the image. Now, when we do a transformation, we can change the size, we can change the positioning, or we can just simply change the orientation. Okay, and with that being said, that kind of goes back into what we just talked about. All the four different types of transformations we have. We can have a reflection. We can change translation by sliding it across. We can reflect it across a certain axis. We can rotate it around the origin, or we can dilate it. And dilating means make it bigger, or we can make it smaller. Okay, so now today we're focusing on reflections. Okay, and reflection is the same thing as when you look in the mirror. When you look in the mirror, you see your reflection. Okay, so that's what we're talking about. We're going to be reflecting these different shapes and these different polygons across the axis, both axes. Okay, so the x-axis and the y-axis. So a reflection, what is a reflection? A reflection is a flip over a line called the line of reflection. Okay, line of reflection. Okay, so now each point and its image are the same distance from the line of reflection. So the x-axis and the y-axis are common lines of reflection. Okay, that's usually what we rotate, usually what we call the line of reflection. Every once in a while, you'll have a rare case where they might reflect it across x equals 2 or y equals 2, but most of the time, we're just going to be reflecting across the x-axis and the y-axis. So let's go ahead and do an example here. Okay, let's go ahead and do number one. And I'm going to zoom in for number one so that you all can see very closely exactly what's going on. Okay, so it says triangle ABC with vertices A at 1, 6, B at 8, 3, and C at 4, 2 in the reflected across the x-axis. That's the reason why the x-axis is bold right here. They want you to reflect it across the x-axis. So the first thing we need to do is plot all these points. So that's what I did. I went ahead and plotted 1, 6. So 1, 6. I plotted 8, 3. So 1, 2, 3, 4, 5, 6, 7, 8, and up 3. And I also plotted 4, 2. So 4, 2. Okay, that's all those different points. This is point C, this is point B, and this is point A. Okay, so now what we're going to do next is we're going to just go ahead and reflect these across the axis. Okay, we're going to reflect it across the axis. So notice how point C is 2 spaces from the line of reflection. Our line of reflection is the x-axis. It is 2 units from the x-axis. So when we put it down here, it's just going to be 2 units as well. Okay, same thing for B. Okay, notice how B is 3 units from the x-axis. So when we look down here, it's also 3 units from the x-axis. Okay, and last but certainly not least, we also have A down here. If you look, A is 1, 2, 3, 4, 5, 6 units from the axis. So when we plot A prime, it is also 6 units from the axis. So 1, 2, 3, 4, 5, 6. Now, I want to point out a couple of things for you guys. One, I want you to notice how the original points are A, the original vertices are A, and and B and C. And now the image vertices, once we reflect it, once we do the transformation, become A prime, B prime, C prime. That's how we know that this is the original point, and these down here is the image. We know that this is the pre-image because they don't have that prime there. We know that this is the image because it has the prime. Okay, so now when we compare these points, okay, first now we need to just say what this point is. Well, this point A ended up being 1, -6. This point B ended up being 8, -3. And this point C ended up being 4, -2. So if we compare and contrast these two, the pre-image points with the image points, we tend to notice a trend. If you look at A was originally 1, 6, but A prime is 1, -6. Okay. Look at B. B was 8, 3, but B prime turned into 8, -3. And last but certainly not least, C was 4, 2, and C prime is 4, -2. So one thing I want you to notice is that these, on all of these different transformations, and when we reflected it across the x-axis, all of the y values change to their opposites. And that's exactly what the rule is when we reflect across the x-axis. If we reflect over the x-axis, all we need to do is change the y coordinates to their opposites, and we have exactly what the new coordinate is going to be. Okay, so let's do an example where we reflect across the y-axis. Okay, so let's look at it. We plotted all these original points. Okay, so this point here, 2, 1 is J. This point here, 1, 2, 3, 4, 7 up here is K. Okay, this point here, 5, 0 is M. And last but certainly not least, this point here is our L. Okay, so now we already plotted those points, and now they wanted us to reflect across the y-axis. Notice I went ahead and highlighted the y-axis just as a reminder. This is our line of reflection. So now we need to plot this point. So you look at this one is 1, 2, 3, 4 spaces from K is 4 spaces from the y-axis. So we have to do the same thing over here for K prime. 1, 2, 3, 4. And as you can see, Mr. Samuels made a mistake. So I'm going to fix this really quickly. 1, 2, 3, 4. Good, right there. Okay, so now let's go ahead and do, and that's K prime. Let's go ahead and do L. L is 1, 2, 3, 4, 5, 6, 7 units from the y-axis. So now we need to count L prime. 1, 2, 3, 4, 5, 6, 7 units. Okay, and that's right here. Okay, and that's exactly what we have. And this is L prime. Okay, and here is J. So J is 2 units from the axis, and we have 1, 2 units from the axis. Okay, and last but certainly not least, M is right here, and M prime is going to be right here. Okay. M prime. Okay. Now, let's compare and contrast these original points with the new points. Okay. So J was originally 2, 1. Now it became -2, 1. K was originally 4, 7. Now it became -4, 7. L was 7, 6. Now it became -7, 6. And last but certainly not least, M was 5, 0. Then it became -5, 0. So now one thing you notice, when we reflected over the y-axis, the x values change to their opposite. And that's exactly what the rule is. Reflect over the y-axis equals a change the x coordinates to their opposites. Okay, so now you guys are going to go ahead and complete the rest of the even problems, but before you end that, just want to reiterate what that rule is. Okay, so if we look at this, okay, when we reflect, let me zoom out a little bit so we can see both of them at the same time. When we reflect over the x-axis, we change the y coordinates to their opposite. When we reflect over the y-axis, we change the x coordinates to their opposites. Remember, you guys are going to go ahead and do all of the rest of the even problems. This is Math with Mr. Samuels and Ms. Brunell. Have a great day.